Hello class, today we are going to learn about solving system of linear equations by graphing. In previous units we have learned how to solve linear equations by substitution and elimination. This unit will be, we will still be using the y equals mx plus b form, but we will be applying it to graphing, which is just like another way to solve linear equations.
So these are the definitions you need to know when doing these type of problems. A system of equations is a set of two or more equations with the same variables. And then variables, they're usually a symbol, normally a letter like X or Y or Z. These are the most common used, representing an unknown number. And then going to graphing, because it is one of the most important things. So coordinates is a pair of points on a graph. So say I just do a graph and do a point, this would be a coordinate to whatever number it goes to. And then an ordered pair is what's written down. So say this point is 3, 4, that's what would be an ordered pair right there. And then an intersection, you can see right here, this is an intersection where another point where two lines cross one another. Kind of creates like an X. And then these are different type of lines that can be the outcome when doing these type of problems. So intersecting lines are usually just one solution. So the one solution would be this point here. And then parallel lines, no solution because they're not interfering with one another. And if we were to continue these lines, they would just go on into infinity. Same line. Oh, and these usually mean that the slope is the same, but the y-intercept where it crosses the y-axis is different. And then same line, it has the same slope, same y-intercept. And so you could see it as the intersecting each, but in reality, there's really no. So yeah.
This is the first example to showing how to solve linear equations by graphing. So we're going to start with the first equation, which right here is 2. So that's the y-intercept. So you're going to go up 2. And then since this is an x in most equations, it's just a 1 next to it, but it's like right there, but people don't really write it. So just associate that with a 1. And because it's a 1, you would just go up 1 over 1. So you're going to start at 2, and you go up 1 over 1. So then your first point will be right there. And then you go up 1 over 1, yada yada. You do that, and then you go down like that too. You do that a couple times, and then that's going to be your first line. So you'll just connect the dots. That line's really uneven, my apologies. And then so this one you do the same thing, just you'll start at 3. So you go 3 and then go up 1 over 1. You do that. You don't have to go up much because you can tell it's not going to intercept up there. You go down, so you go down 1 over 1. And then this will be your second line, which again, oh, that's very wavy. And in this equation, since these are both x's, they're parallel. So that means there's no solution.
So this is the second example. As you can see, these equations are not in the linear format because usually it would be just y equals mx plus b, but in this case, one is in a different format. So when this happens, right now I'm gonna take the equation itself. So 2y negative 4x equals negative 8. So when this happens, y should always just be on the left by itself. It should be isolated from the slope and the y-intercept. So basically what you would do is just do plus 4x, which would cancel this out, making it just be y equals positive 4x minus 8. Then when the y has a number in front of it, you then divide it by whatever the number is. So in this case it's 2 divided by 2. Divide everything by 2, so 2y divided by 2 would be y itself. Then then 4 divided by 2 would then be 2x, and then negative 8 divided by 2 would be negative 4. So now we have both our equations in the y equals mx plus form, so I'm just going to write this down again. Negative 2x plus 8. So then here we come with the graph. So I'm going to graph this one first. So negative 4 on the graph is right here. So from there, so there's something called rise over run. Rise over run. And basically, so we could make this into like a fraction too. So in reality, you go up by 2 and run like to the side by 1. So from doing that, we would just go from negative 4, which is here. Then we're rising up 2, so 1, 2, and then to the side 1. Rise up again by 2, go right by 1, rise again, and then just repeat the same thing. And then when going down, you want to keep going by your y-intercept, but just go the opposite way. So go down now and go to the left instead of the right. Okay. So this is our first line. Oh, this is really bad. This is a really bad line. But hopefully I can still get the. So that's line number 1. That's equation one of the first equations, and then the other equation. Now our y-intercept is positive 8. So from 8 we're gonna go down. So go down to 6, then to the right, down 6. And then so then continue. And then you see that. So we're gonna draw this line. Although it's not really perfect, you can see that this is when both lines intersect, and so this is the point or ordered pair. 3, 2. So this would be one point or one coordinate, or the solution, the one single solution for this system of equations.
Okay, so this problem is a little bit different from the other two we did, because there's a fraction for the slope instead of like just a number, and it's basically like we still graph it the same. So we still start with like the y-intercept first, which is 4, which is right here, and then since it's negative, we're also going down. So it's like it's like 1 on the top of the fraction, so we go down 1, and then since it's 2 at like the bottom of the fraction, we go to the right by 2, so it'd be like right here, and then we just like repeat what we just did. We could also do like the opposite of it, which is going up by 1 and then to the left by 2. And then and then you could just draw like the line. And then the next one, this one is just like a normal one with like just a number for the slope. It starts with -3, so right here. And then up by 3, and 1. We could still like go down, but it's not necessary because we already have our intersection. But I'll just like do that. Okay, we can see that our intersection is right here, which is the point, 2 and 3. And then that's our solution.
So for this equation, you can kind of tell it's a little bit different when it comes to the first one, but we'll get to that later. Let's first move everything in this one to get this y alone. So all you really do for this one is you gotta subtract the 2x from each side, so then you just got y equals 1 minus 2x. And normally you just have like those flip-flops, but it still works this way because you just do this one first. But anyway, for this equation right here, this is x equals 2. Now it's not now you can tell that it's not y equals mx plus b, because there's no y part of it. But that is not needed for this part, because what you do for this one, since it's just x, you just go to the x-intercept, or the x line, the axis, and you go to 2, which is right here, and then you just draw a straight line up and down. And but if, for example, if this was y equals 2 instead, you do the same thing, but you just go on the y-intercept and get a line right here. But it's not that for this equation, but it's like the same thing. They're pretty easy. Now, for the x, we want the line to pass through it, so we're just gonna go for a straight line down. It's kind of a bad line, but it's good enough. And then for this equation, we're starting at 1, so that's your first point. And then because this is a negative 2, you're gonna go 2 up, so that's 1, 2 over 1 to the left. Because for a negative number, you want the line to be going down from left to right. So then we're just gonna finish off that line. And for the most part, you don't always have to go all the way on both sides, as long as you get your intersection. So that's a really bad. The intersection is supposed to be right there. But your intersection is right there. And that point is, so in this case, that would be 2, negative 3. And that's your answer.
So here's another case of where you have to move the, in this case, the slope and the y, because the y is not isolated. So I'm gonna take this and just rewrite it. 6x equals 4. So we're gonna do plus 6x to move it to this side. So now we have 2y equals 6x plus 4. And then since this is 2y instead of y by itself, we're going to divide it, everything by 2. So 2y divided by 2 would be y itself. 6 divided by 2 is 3x. 4 divided by 2 is 2. Now you may have noticed that these two equations are the exact same. So when this happens, when you graph it, so let's go back to the graphing. So both of these have 2 as the y-intercept, and then 3 as the slope. So go up 3, I think. Go up 3, y, go up 3, go down. These are the exact same lines, so no matter how you do it, they're gonna be the same. There's no intersection, because they're the exact same. So the same line. So yeah, and that's it.
Okay, Sam is trying to decide whether to pick Lyft or Uber. Lyft charges $5 as an entry fee and 50 cents for every additional mile. Uber charges no entry fee, but charges $3 every additional mile. when will the two companies cost the same? First I just wrote down these to like help me remember which one's which. And first I'll write it for Lyft, and then so just y equals we can see that like the 50 cents is for every like mile, which means that it's like not just like a flat fee because it will like change depending on how many miles there is. So we could label that with like x. And like 50 cents, since it's like half of a dollar, we could just write it as 1/2. And like the x, or this is the bottom too. X equals like the number of miles. Yeah. And then we could see that it charges like $5 as just like a flat fee. So we will add on like 5. Cause like the 5 isn't gonna like change depending on the number of miles. For Uber, we could see that they charge $3 like every mile, so it's 3x, and then plus 0 because there's no entry fee, and then I'll start graphing. So we'll start at 5 because it's the y-intercept, and then we're gonna graph it. The 1/2.
Excuse me?
Yeah.
Isn't it supposed to go the other way because it's a positive slope?
Oh yeah, you're right, cause it's like it costs 50 cents more, so it should be going the other way. My bad. Thank you for pointing that out. Okay, so we're still gonna start at 5, but so we're gonna go up by 1 and then to the right by 2, up by 1. Okay, and then that's just our line for Lyft. And then for Uber, we're just gonna start at 0 because that's the y-intercept. And then go to 3 and then 1. Okay, we can go down to let's draw this line. Okay, we can see that it intersects right here, which is 2, 2, 6. And for this one, since we're trying to find when the two companies will cost the same, and then x is like the number of miles, which means that y would be the cost. And that makes sense because like these are like the, I guess like the dollars, and then this would add up to like the total cost. And then basically then we can see that we're looking for the cost, so we're looking for the y, so which is 6. So, and then we could just write that out as Sam will, wait, I should know, but alright, the two companies will charge the same when when you like buy 2 miles, or like when you go 2 miles. And then like the cost will be like $6. And then yeah. That's all.
Bloopers.
I'm recording. Yeah. I'll first graph the one for Uber because like it's easier, so I'll just graph that first. So it starts at 0, and then it goes up by 3, and then 1, 3, 1, 1. And then what's on here?
Should we restart?
Wait, why is there nothing?
No, no.
No way! You did, I didn't make my pen. Like,
Oh my
Oh.
Because I lost my mind, it looks like me.
Okay, hold on, I did it wrong. How do you spell solving?
Wait.
LV. Wait, solve. LVING.
Okay.
Hi, hello. Hello.
Okay, let's see.
Oh shoot, wait, I'm not supposed to have my phone in there. Okay.
That's a little bit too low. Just like that.
What am I gonna say?
Just be like, that's all for today. Thank you for watching or something.
That's all.
Okay.
That's
This is.
oh we should be like how he does it. Make sure you do the group work. Make sure 11:59 p.m.
Yeah. Okay, that works. So
Who's
who's
saying it? Because I'm not saying it.
I'll say it.
Okay. Wait. Maybe this is on time. Okay.
All right, everyone. Class dismissed. Make sure you do the group work. It's due at 11:59 tonight, and your homework will be assigned later as well.
Bye.